Alright, so I told you I'd show you another Pythagorean triple. So here's one we got. So again, we're going to start with our formula. A squared plus B squared equals C squared. And here I have a 5 by 12 right triangle. So I'm going to do 5 squared as my A squared and 12 squared as my B squared. And that's going to give me my C squared. So 5 squared is 25. 12 squared is 144. That's going to equal our C squared. Well, 25 plus 144 is going to be 169. That equals our C squared, and the opposite of a square is a square root, so I square root both of those. So the square root of C squared leaves us with just C, and the square root of 169 is 13. So another Pythagorean triple is the 5, 12, 13. And again, you can multiply this by any number. So if I multiply it by 2, I'd have a 10 by 24 by 26 triangle. So that too would be a Pythagorean triple. So what happens when we don't have a Pythagorean triple? Let's look at some of those ones. So say I have a triangle that is a 3 by 3. So we start with our formula. A squared plus B squared equals C squared. And our A is 3, so I'm going to do 3 squared. And our B is 3, so I'm going to do 3 squared. And that's going to equal my C squared. 3 squared is 9, plus 3 squared is 9, equals our C squared. 9 plus 9 is 18, and that's equal to C squared. So again, to undo a square, you square root it. So C squared square rooted would give us just C. And then we have to do the square root of 18. Well, square root of 18 is not a perfect square root. So we have to think which numbers are. Well, 16 is a perfect square root, and 25 is a perfect square root. So 18 is closer to 16, so we could estimate this as about 4. It's a lot closer to 16 than it is 25, so if you're trying to do a little bit better estimation, you could call it 4.2. That'd be close enough. Or if you were to use a calculator to estimate, you'd get an answer of something like 4.24264. Again, this is an irrational number because it was not a perfect square root. So anytime you have a number that isn't a perfect square root, it's going to be an irrational number. And later we'll give you some other ways to deal with irrational numbers. But for right now, just estimating it is good enough. And depending on what you're asked to estimate, you can get closer and closer, like we did with getting 4 and then 4 and 2/10 and then 4.24264. But they're all just going to be estimations. So let's go over one more example. Alright, so now we got another triangle. It's a 2 by 9 triangle. So again, we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. My A is 2, so I'm going to do 2 squared, plus my B is 9. So we'll do 9 squared equals C squared. 2 squared is 4, plus 9 squared is 81. And that's going to equal my C squared. 4 plus 81 is going to be 85, and that's equal to C squared. To undo a square, you square root them. So C squared square rooted is just going to give you C. And square root of 85, we can estimate that. The perfect squares around it are going to be 81, which is 9, and 100, which is 10. So 81 is a lot closer to 85 than 100 is, so that's going to be about 9. So we could estimate it as about 9. If we want to get a little closer, it's much closer to 81. So again, you could say it's about 9 2/10. That'd be reasonable because it's not anywhere close to halfway. Halfway would be in the 90s, about 90 and a half. Or you can use a calculator and estimate, but again, it's still an estimation. And you'd get something like 9.21954, etc. And again, that's an irrational number. In my next video, we'll cover what happens when you don't have one of the A's or B's.